Hello guys, welcome back to our video series of modeling and simulation. We are going to continue with dynamics. System dynamics. Remember in the previous videos we have covered the first method of simulation, so which is agent-based modeling. Now we continue with the second method, which is system dynamics. So remember that we said system dynamics is uh, is used to model and simulate, model with high abstraction. So the system dynamics is more appropriate when it comes to model system with high abstraction, like social systems, like human resource system, like market, and so on. So let's have a little introduction about it. So the system dynamics method was created in the 1950s by MIT professor Jay Forrester. Drawing on his science and engineering background, Forrester sought to use the laws of physics, in particular the law of electrical circuit, to investigate economic and social systems. So you see, this guy called Forrester, used his background as engineer to apply this to economic and social system. Remember, we say that system dynamics, and we are from saying it that system dynamics is meant to uh, is meant to model social system, economic system, market system, where we find, a lot of dynamics. Today, system dynamics, I'm ready. Today, system dynamics is typically used in long-term strategic model, and it assumes high level of object aggregation. System dynamics represent people, product, event, and other discrete items by their quantities. System dynamics is a methodology to study dynamic system. It subjects you to model the system as a causally a causally closed structure that defines its own behavior. Discover the system feedback loop, circular causality, balancing or reinforcing. Feedback loops are the heart of system dynamics. Feedback loops are the head of dynamics. So identify stocks what we call accumulation, and flows that affect them. Stocks are accumulation and characterize the system state. They are the memory of the system and source of disequilibrium. The model works only with aggregates. The stock items are distinguishable. Flows are the rates at which the system state change. Now, what you guys should understand is that in system dynamics we have two main concepts: the the concept of stock, which which are accumulation, and the concept of flow, you know, which the concept of flow, which affect the stock. So we're going to see that with example, but before we get a stock and flow diagram, we have we have causal diagrams. In causal diagrams, we have feedback. We have feedback loops, between different variable and constant in the system. So we are going to see that in details. So the rest of the text, we are not going to spend time reading it. Now, what are the objectives here in this unit? Upon completion of this unit, you should be able to understand what is system dynamics, know the difference between system dynamic and other two methods used, model and simulate a problem using, a system dynamic approach. So let's define key terms. What is a system? In general, a system is a collection of interacting elements that function together for some purpose. Here, feedback is the differentiating descriptor. Feedback occurs when output of a system are routed back as input as part of chain of cause and effect that forms a circuit or loop. So you can see here, what is the feedback? We have input here, and then the input is processed to have output. A feedback is when an output branch back, branches back, when an output branches back, to be an input. So this is a feedback. So now you are going to, what is a system dynamics? System dynamics is a perspective and set of conceptual tools that enable us to understand the structure and dynamics of complex systems. System dynamics is also a rigorous modeling method that enables us to build formal computer simulation of complex systems and use them to design more effective policies and organization. So this is the history of system dynamics. So you guys can learn about it. Now, this is the first activity. In this first activity, we are going to learn about causal graph. Cause and effect graph, or causal graph. Now, briefly, how does system dynamics work? So you identify a problem, you develop dynamic hypotheses explaining the cause of the problem, you create a basic structure of a causal graph, you augment the causal graph with more information, you convert the augmented causal graph into system dynamics flow graph, what we call a stock and flow graph. Now, if you want, you translate a system dynamic flow into Dynamo program. But here we are not going to use Dynamo, so we are going to use any logic. So we are going, before we move into practical, we are going to see how to design causal graph, and how to design stock and flow diagram. So after designing the causal graph and translating it into the stock and flow diagram, or the stock and flow graph, then we will be able to use any logic to model and simulate. So these are the critical steps involved. This is critical. Thinking in terms of cause and effect relationship, focusing on the feedback linkage among components of a system, determining the appropriate boundaries for defining what is to be included within a system. So these are critical steps that are involved in system dynamics. So let's start with the cause and effect diagram. So we are going to start in the next video. We are going to start by understanding what are causes, what are effect, but these are something you already know. So let's cover it in the next video. So I hope you guys have enjoyed the video. So thank you for watching. See you in the next video. Bye bye.